Hey guys, Testy here. Get ready with me to show you a day in my life. First, I commute to my job as a testosterone molecule. Testosterone is the primary male sex hormone responsible for driving the development of male tissues, secondary sexual characteristics, and overall masculinization. Beyond reproduction, it also plays a key role in muscle and bone growth, making it an essential part of our life, if I do say so myself. In this vlog, I'll show you I'll show you a behind the scenes adapt, overcome, improvise. I'll show you behind the scenes of how testosterone signaling results in the development of fetuses through intracellular and hydrophobic receptor proteins. Let's go! Ben, since I'm so famous, I got to meet with you guys today. I love my fans. She asked me about my work, so I explained a bit more in depth. I told her that testosterone is a hydrophobic signaling molecule, which means it is able to diffuse easily across the lipid bilayer, as they are both nonpolar. Easily. There we go. Since it is able to cross the cell membrane, its receptor protein is located in the cell. The benefit with this is that they form hydrogen bonds together, meaning that the change is slow yet long-lasting, as opposed to the weaker bonds formed by hydrophilic receptors, which cause quick but temporary change. It also directly changes gene expression of the DNA, so it has permanent effects. These type of receptors are used for puberty, which makes sense because that is a gradual permanent change. The disadvantages, however, are that certain hydrophobic toxins like BPA can mimic the appearance of the ligands and bind to the receptors, causing harm to the cell and to the body. Hydrophobic receptor proteins work by first binding to the hydrophobic ligand that crosses the membrane, and then this binding changes the conformation of the receptor, which allows it to enter the nucleus, like this one that we already have in here. In the nucleus, it binds to specific sequences of DNA, which either turn on or off these target genes, which can change protein synthesis and function of a cell. Thank you. I got to work, guys. Time to introduce you to my coworkers.
First of all, we have the stimulus, which is responsible for genetic sex determination. And then we have the testosterones, which are the signaling molecules or ligands, which is also a hydrophobic steroid hormone produced by Leydig cells in the fetal testes. And then we have the receptor, which is AR, or androgen receptors for short, which is an intracellular receptor protein located in the cytoplasm. And then other molecules includes the heat shock proteins, HSPs, that keep the receptor inactive, androgen receptor testosterone complexes, and nuclear transcription machinery, such as co-activators and RNA polymerase.
I hate HSP. He's such a bad coworker. Always microwaving 6 to 7 fish sticks in the work microwave. Ugh.
The first step is synthesis and release of testosterone, where the developing testes produce testosterone after being stimulated by SRY and some other factors. The next step is the diffusion of testosterone into the target cells. Because of the hydrophobic properties, testosterone passes through the plasma membrane into the cytoplasm of the cell. Then testosterone binds to the androgen receptor, or AR, causing conformational and shape changes and dissociation of inhibitory proteins, which is HSP. Now that the androgen receptor testosterone complexes are activated, they move into the nucleus. The complex binds itself to specific DNA sequences called ARE, androgen response elements, binding to other specific receptors and proteins, causing activation or inhibition. The intended response is either increasing or decreasing the activity of a certain gene. Specifically for testosterone, this manifests as male sexual differentiation. This will ensure that the fetus develops male reproductive organs and male subset characteristics. This signaling also establishes the basis for puberty developments later on. Termination of the signaling pathway may happen through hormone degradation by having testosterone being metabolized by enzymes and cleared from circulation. Another way for termination is receptor inactivation. Once rebound, the androgen receptor AR can be recycled or degraded. Feedback inhibition can also be used. These mechanisms involve the hypothalamus and the pituitary regulation of testosterone production. Lastly, termination of the pathway can be achieved when the hormone receptor complex completely dissolves. This allows the cells to return to baseline activities.
Testosterone's receptor is called the androgen receptor, or AR. There are a lot of molecules that can mimic the size, shape, and charge distribution of testosterone and are able to replace it by binding to the receptor instead of testosterone. But we all know I'm the original, they're just copying my videos. Okay, whoa there. These can be both exogenous and endogenous, and antagonists and agonists, meaning some can replace testosterone but keep the pathway going or even increase its efficiency, but some stop the signaling pathway altogether when they are bound to the receptor instead of testosterone. An example of an agonist is dihydrogen testosterone, or DHT, which is produced by the body, meaning it is endogenous and it's a bit more potent than testosterone. It's only because DHT is a nepo baby. If he wasn't, I would have more followers on Instagram than him. The response in the cell signaling pathway is hardly altered, but since DHT is a bit more effective than testosterone, it's actually a bit increased when it binds to the receptor instead of testosterone like so. The effects of this can be manifested as male pattern baldness in men and acne, but interestingly, it increases hair growth in women. Women, we're just better. One antagonist of testosterone is flutamide, which, when bound to the AR receptor instead of testosterone, blocks the cell signaling pathway completely. It is exogenous and taken for cancer and PCOS. The response by the cell, therefore, is non-existent because it never received the message. So the typical effects of the testosterone signaling pathway would be absent. The effect of this that we can see varies depending on the life stage a person is at, but in adults it can lead to reduced bone density and anemia. What the celly?